I love the first person that clapped. Where are you? High five. A round of applause for this man up here. Started the clap for the presenter. I like it. Hey, everybody. Welcome to day 3 of Google I/O. Yeah? We feeling it? Everyone properly caffeinated today? No. OK, good. Good to know where we're starting off as a team here, all together. So I got to tell you, when we actually got this talk agreed upon, they came to me. And they said, all right, we love the title of your talk, GCP on a shoestring budget. We love the narrative that you're trying to bring, helping developers save on money. When do you want to give the talk? And I had one answer. I said, day 3, 8:30 in the morning. No other possible opportunity there. And you want to know why? Because the people who are willing to go through 2 days of standing in the sun and wake up at 6 a.m. to stand in the security line, to get in the seats by 8:30, they care about saving money on Google Cloud Platform, right? Yeah, exactly. So thank you for being here. Now, when we get a chance to talk to a lot of developers around the world, I find that there's generally 2 buckets of people, or 2 buckets of companies that companies fall into when you're talking about saving costs. The first one is your large companies with established code bases. They may have expected workloads that come through Google Cloud, but the predominant conversations we have are, hey, if you make this change and this change, you can save a lot of money. And their response is always along the lines of, well, how much would that cost to implement? We've got this legacy code base. Bill over here really is attached to that API. We really don't want to get rid of that. Basically, any conversations we have with these individuals, they always have an opportunity cost trade-off that they have to make in their head before they're willing to actually make the changes to save the money, right? On the other side, though, are the hustlers. The rise and grind, right? The startups. The people living customer to customer every single day, trying to get those costs as low as possible because they know that that's the key to keeping their business afloat right now. And those are the people, hopefully, that wake up so early after 2 days of sunscreen and dehydration to come to this sort of talk. And that's who we're talking about today, all right? Now, Google Cloud Platform is huge. We have a ton of different products. And quite frankly, the 40 minutes that they've given me here, we don't have enough time to go through all of them. So today we're going to focus on 3 main things. Number 1, we're going to lay some foundation on the network and show you how to save a little bit of costs there, just to kind of ease everyone into what we're talking about. Then we're going to talk about some ways to save costs on compute. And then we're going to go through a couple scenarios that hopefully some of you fall into and you'll have a little bit better time attaching to your business model. But the most important thing you need to know is that nothing I'm talking about today is secret. Like, none of this requires a handshake or the right Google badge to get this information about how to optimize this stuff. Every piece of data you're seeing today is available for you to go get right now, either using the Google Cloud Platform pricing calculator or looking at the pricing pages for the individual products. Like, this is it. Like, again, it's not an Illuminati-style thing here. Like, you can go run the same analysis on everything you're doing on your own. So let's get started. Serving data. This is where we're going to start today. Let's figure out what does it cost to serve 1 terabyte of data from Google Cloud Storage to your users, right? Just bare minimum discussion here, right? Let's just talk about serving data. Now, when you think about this, you have 2 components involved. First off is storage, where you're storing your data. And second off is your network costs for actually transferring the data. Now, the costs for these are dependent upon usage. So for example, Google Cloud Storage, what you pay is a function of where you're hosting your data alongside of how much you're hosting it. So for example, if you're actually hosting your data in US Central 1 region, you're paying about 2 cents per gig to actually store your data. However, if you move to US East, that changes. And if you're using a multi-region bucket, then that changes as well. On the networking side, it's a tiered cost structure. So if you're under 1 terabyte, you pay a different price than if you're in the next tier of 1 terabyte to 10 terabytes and 10 terabytes up. And then this also changes per region as well. So for example, if you're transferring data from the Iowa location, which is US Central 1, and you're in the first tier of under 1 terabyte, you're paying about 12 cents a gig. Okay? Now, with this in mind, though, we have to point out something. And again, this is not secret. This is widely known, is that there's a whole tier of usage on Google Cloud that's absolutely free, that you get every single month, that you can just use this stuff. No one cares about it. You're not going to get charged for it, right? And this is, it ranges from mostly all of our products. But most specifically for our case right now, we're worried about what is the free tier for network and storage. On the storage side, we actually get 5 gigabytes of storage for free each month, each region. So if you've got 5 gigs in US East and 5 gigs in US West, each one of those is free, right? On the network side, we get about 1 gigabyte of egress, which is outbound data traffic from North American locations to other destinations. And by the way, you will see many caveats of little stars during this, and you'll also see a lot of little labels that says the price of today, right? This is the cloud. Prices change. And if you discover this video in the future, you will undoubtedly find that there's a discrepancy in the prices. So please make sure you check out the documentation for the latest. So this is our free tier. Let's talk about egress cost then. So 1 terabyte of data that we want to send. So what would this cost us? So to store it, we get about 1 terabyte of data storing in US Central Run. That's 1024 gigs minus our 5 gig free tier at 2 cents per gig, about $20 a month, just to store the data at rest. Not too bad. On the network side, though, things get a little bit trickier. So we've got our 1 terabyte of data minus the gig in the free tier at 12 cents per gig, about $122 a month for a total about of $143. So storing the data, transferring a terabyte of data, about $143, which isn't too bad, I don't think. But the truth is that most of you actually don't send your users directly to your cloud storage bucket. Chances are you have some proxy, some front end that they're hitting first if you're a website or something else that this data is being routed through. So let's take a look at what that costs. Basically the same. So as long as you're transferring information in the same region between a cloud storage bucket and a proxy or a compute engine instance, it's free. You don't have to worry about that, as long as it's in the same region. And then your egress rates are still the same if they're coming from compute engine or from cloud storage. So basically, if you're transferring all your data through a proxy, you're paying the same exact price as you would if it was going from cloud storage directly. The only difference is that you're now actually paying for the compute engine instance running there, or the compute function, the cloud functions instance, or the app engine instance. So basically, as long as you're using a proxy, the basic serving costs don't change. But let's look at this from a different way. When we serve data to people, especially through cloud storage, one of the things we care about is locality and latency. So we want to get our data as close to our users as possible. But we also want to do it as cheaply as possible, right? So let's take a look at that scenario. So let's say we're serving our data here. We've got it in US West 1, and we want to serve it to a user in US East 1. So we're going across the continental US, right? Price here is still the same, $143. Doesn't matter where the user's coming from. We still have the same cost at rest and the same egress costs. But we want to get that data closer to the user. So what if we actually cloned that data in US East 1 and got it closer to the user? Well, of course, at this point, our egress is still 12 cents. No change there. And cloud storage itself, we're now duplicating the data between 2 buckets. So of course, we're paying that extra 2 cents a gig to copy it into this other location. So we're doubling our cost for storage. And we also have this extra 1 cent per gig transfer cost between them, because we're moving our data between regions. So now we actually have a cost that's incurred with that. So to actually clone this data between regions, we're actually looking at $173. Not ideal, but it gets our data a little bit closer. But truth is, we might be thinking about this the wrong way. So we do have these things in Google Cloud Storage. We have regional buckets and multi-regional buckets. And what multi-regional buckets do is effectively duplicate your data between regions in an area so that you don't have to do this cloning by yourself. The trick, though, is that multi-regional buckets cost a little bit more. So let's take a look at that. So if we want to go from cloud storage right to our users, our egress rate from a cloud storage multi-regional bucket, by the way, there's going to be lots of weird acronyms and terminology in this talk. It's labeled intermediate, so hopefully we're all moving together. 12 cents per gig egress. However, we're paying 2.6 cents per gig to store in a multi-regional bucket, which puts us at about $26 a month for that storage instead of what we were paying for the single region. We're at about 149 there, so not too much cost change. But the difference here is that when a user in US East 1 actually asks for this asset, Google handles the duplication of getting that data closer to the user on your behalf, and you don't have to clone it yourself. So we basically just saved an extra $30 by using a multi-regional bucket per month instead of actually cloning it ourselves. OK, sounds good. So we've actually reduced our cost inside the regional US. But what if we want to go international? So we want to serve this data to someone in Europe, right? Well, let's take a look at cloning there as well. So again, we have our clone data in a US multi-region and an EU multi-region. So obviously, we're duplicating our costs. We have the same amount of cost egress for the EU multi-region, which is selected for these numbers. However, now because we're transferring data between multi-regions in different areas, we're actually at 12 cents per gig transfer. So we actually get a little bit pricier there. 286 as a result of this. So if you're trying to get your data to users in a different area using the multi-region, it's actually really expensive. But let's rethink this here. So the goal, again, we're shoestring, right? We want to make this as cheap as possible. We want to get data from the cheapest bucket we can store in to the farthest away user as fast as possible, as cheap as possible. We already have this. It's called the CDN, right? We've all been working with these. So let's figure out what the cost is of that. So we've got our standard regional cloud storage in in EU West at about 2 cents a gig. Now, for CDNs, there's two costs you need to be aware of. We have a fill cost and an egress cost. To fill data into the cache, you're looking at about 4 cents per gig to get it into the CDN. And that's worldwide. Doesn't matter where you're going. So if you have data here and someone in Nairobi asks for your asset, it's 4 cents per gig to cache it. It's to the closest point of presence that Google has there. Now, egress from the CDN is only 8 cents per gig. So when you combine these two together, 4 cents and 8 cents, you actually end up at about 12 cents per gig, which is your standard outbound egress rate. However, this is assuming a 1-to-1 ratio. So if you're actually pushing a terabyte of fill and serving that same terabyte, you're going to end up at about $143 to get that asset as close to every user in the world without you lifting a finger, except making sure your cache headers are turned on properly. But in reality, this isn't how things work out, right? Typically, the amount of cache fill versus cache serve are quite different. So if you're actually in an 80-20 split here, where 20% of your data is filled into the cache and 80% is actually served out, you actually only end up closer to about $91. So as long as that ratio is on the serving side instead of the filling side, you're going to have a lot cheaper representation and setup. You're going to get closer to that shoestring value you want. So in general here, if we're looking to serve a terabyte of data, the cheapest thing we can do to get it to users across the world as fast as possible is simply to set your caching headers. Any other tricks or any other smartness that you're trying to do is going to blow that up, right? It's going to make things more expensive. So find the cheapest bucket that's as close to you as you can tolerate, put your data in that, and then turn on the CDN and let Google's point of presence network handle the rest of it. All right, let's talk about compute. So Google Cloud Platform has a lot of compute offerings, but today we're only going to talk about 3 of them. First off is Google Compute Engine, which is our standard VMs that run in the cloud. Second is, of course, Google Cloud Functions, which are our invocation-based compute resources. And third, of course, is Google App Engine, which is both managed and invocation-based. And for the sake of this talk, I'm going to ignore things like Google Kubernetes Engine and GAE Flex, because these actually tend to price themselves closer to what GCE is. But for the sake of this 40-minute talk, we don't have to go into all the nuances. It's a little bit weird. So I'm just going to ignore those. We're going to focus on these 3 offerings for right now. So by cost, of course, GCE is variable on config. Depending on what configuration you're using is how much you're going to pay, right? The beefier the machine that you're using and the configuration, the more you're going to have to pay there. Cloud Functions, though, is a little bit different. Cloud Functions is about 40 cents per million calls that you make to it. And then there's also an additional cost you have to be concerned with, is what we call gigabyte second and gigahertz second. And if you check out the documentation, there's a little bit better breakdown here. I'm not going to get a chance to go through it today. And of course, App Engine is going to be 5 cents to 30 cents per instance hour, depending on your config. So this is the default cost that you have here. Now, on the other side, we have our free tiers, though, right? Now, here's where things get really cool. In Compute Engine, if you're using an F1 micro configuration, it's free the whole month. No cost to you. Free instance sitting in the cloud, doing your bidding as much as you'd like it, all free. On GCF, you got about 2 million invocations a month, or 400,000 gigabyte seconds and 200,000 gigahertz seconds, right? And on App Engines, you have 28 instance hours a day for an F1 instance, and about 9 instance hours a day for a B1 instance, right? And I know there's more than 20, there's less than 28 hours in a day, so that gives you a little bit of wiggle room in case your extra instance spins up in an F1. So, but basically here, when you look at GCE F1 Micro and GAE F1, you kind of get free compute as long as you're under a certain strata of usage, right? With this in mind, let's take a look at an always-on cost. So let's say you want to run a box 24/7 for an entire month. What does that cost you? So months have different days, and we always have leap year and stuff like that. So I'm just going to assume 730 hours of consistent runtime. What we end up with, if we're using an F1 micro, it's free the whole month. Don't have to pay a thing. However, when you bump up to an N1 standard 1 because you want a little bit more performance, you start paying $24 a month and $194 a month for an 8-core machine. Right? This is all on the cloud pricing page. You can see all of this. And by the way, this is after a 30% sustained usage discount, which I'll get to in a second. Cloud Functions, though, we can't really compare apples to apples. Because it's an invocation-based system, we can't just say consistently running. So what I've done here is I'm making the assumption that you're getting 1 invocation to your Cloud Functions service every second for the entire month. So you got about 2.6 million invocations a month that's going on there. That lets us kind of simulate what an always-on cost would be. For this, it's about $3.51. to basically have a GCF function running every second for an entire month. On App Engine, you end up, of course, in the F1 config. It's free. Don't have to change anything there. However, if that second F1 instance actually spins up, you get a little spike in your workload, or all of a sudden you're the top of hacker news for some reason, you're going to pay $36 for that second instance to come on board. Of course, when you move up to an F2 or an F4, which again are beefier machines, you get the $73 and the $146. So basically, across the board here, you can see that in GCE and GAE, as you get a stronger machine, of course, the costs go up, while GCF is still pretty instance-based. Now, here's the interesting thing. So those are our basic costs. So obviously, Compute Engine is the most versatile thing we have, right? It can run whatever code you want, whatever instance you want, your images and all this other stuff. But the problem is it's also the most expensive for what you're using. So it'd be really cool if we could figure out how to make that as cost-effective as our other services without having some of the same limitations, right? So for example, if we just wanted to run our code on GCF, we have a problem is that each function invocation has a 9-minute timeout. Right? So you can't actually get anything for more than 9 minutes. On the other side, on App Engine, you have a 60-second timeout on requests, but if you push that off to a task later, you end up with the same 9-minute timeout. So our goal here is to figure out how to make GCE as cheap as our other alternatives. And the good news is we can do this. First off, let's take a look at the GCE discounts. Now, these are the things that you really don't have to lift any fingers to do to actually turn this stuff on. So first off is sustained use. So what we'll do on Google Cloud Platform is analyze your usage. And if you have a sustained usage, so you're always on for a certain amount of time, we'll give you a default discount for just running your instance with consistency across the entire month. Right? If you're willing to make a phone call to our sales team and can actually commit to usage, specific usage, and say, I'm going to run at least 2,000 hours this month or 730 hours this month. It doesn't matter what configuration you're using and you don't have any pre-definition of specific upfront fees or whatever, you can actually get up to a 56% discount by just making a phone call to talk to sales. So if you're a startup and you're starting to see a little bit more usage and you need that dedicated resource and you're going to at least have 1 or 2 instances running at a dedicated fashion, making that phone call and getting that 56% savings is actually pretty huge. And of course, right sizing. So what will happen is Google Cloud Platform will actually analyze the usage of your GC instances and look at how you're using them and actually tell you whether or not you're over-provisioned or under-provisioned. And you'll see a little icon appear on the homepage that'll say, hey, if you click here, we'll reconfigure this for you and save you money every month. Likewise, it'll say, hey, you're using this pretty hard. If you click here, we'll beef up your machine so that your users get lower latency. Right? So it's a fun little button that you can just click. The deployment happens behind the scenes. You don't have to do anything. So this is kind of automatic stuff. However, something that's a little bit more drastic in terms of saving that does require a little bit of work on your part is something called preemptive. Now, what preemptive VMs are means that the scheduler is allowed to kill your instance when we need the resources in Google Cloud. Now, that may sound really scary, but here's the fun part. It'll actually alert your instance before it's about to get killed. So it'll send you a message, and your instance will say, hey, I'm about to terminate you. You've got roughly about 30 seconds to back up any data to some persistent resource. And then once it kills your instance, it'll start your instance back up later, and then you can then go fetch that data and continue working on. Right? So if you allow us to kill your instance when we need the time, we actually give you a substantial discount. If you're running an N1 standard that's preemptive, instead of paying the $24 a month, you get a 3x discount down to about $7 a month. For the same instance, and all you do is have to write the code so that you can lay over those sorts of terminations after time. And the cool thing is that you can actually put a load balancer in front of that. So if you need scalable compute and you need the ability to allow these things to die, right? But because you've got so much load coming in, one of them going down means another one might have to spin up. Putting a load balancer in front of your preemptive instances, since load balancing is free, again, means you're only paying about $7 a month per instance that you're actually running. Of course, we can get this a little bit cheaper, in fact, if we actually use a micro instance there instead. We can actually get it down to $2.96 per month using an F1 micro. But because of the fact that we have our load balancer, and because of the fact that we've re-engineered our code to make sure that it can be fault tolerant when it's killed, we actually have a massively scalable compute resource that can handle itself getting kicked over. So if you've got large amounts of workloads or individual things, you're processing lots of individual files where something can pick up processing 50% where something else left off, this is an extremely cheap solution for you. Probably as cheap as I was actually able to find in my research. So in general, if you want to reduce your compute costs, you've got a couple things you need to do. First off is distribute workloads that are based on invocations to either App Engine or Cloud Functions. Those are going to be the cheapest situations where you can put your code and have them run. If you need something long running, then leave it back on Compute Engine, but otherwise try to push as much as you can to those resources. That's going to be the cheapest you can get. Likewise, make sure that you're making that phone call to sales. Let them know that you're willing to commit to a sustained use and get that discount, because that's going to be huge for the work jobs that you actually need running consistently on Compute Engine. And likewise, if you have scalable needs, a load balancer plus a micro preemptive instance is pretty much the highest flexibility, lowest cost scenario you can be in. You know, having a bunch of little spiders doing your work for you at scale is just as effective as having one behemoth doing it for a higher price, right? All right, so those are our basics here. So we've kind of laid the groundwork for how we're going to evaluate these things and look at the big picture between network and compute. Now let's talk about some scenarios. Personal privacy matters online, right? We all kind of care about that, especially when we're logging into public Wi-Fi and whatnot. But sometimes I don't like paying a subscription to some other service to handle a VPN service. So how cheap can we build our own personal VPN service on Google Cloud? Now, to be clear here, I know that personal security online is a very hectic area right now, and there's lots of back and forth. So to be very clear, I'm not going to talk today about why you need a VPN. I'm not going to debate the different software and libraries you can use or having your own VPN versus being part of a cluster. I'm basically not going to talk about anything that PR or legal would raise an eyebrow about, okay? But I am going to talk about how you could run your own VPN on Google Cloud for as cheap as possible, all right? So with this, we have two components, compute and network, pretty easy. How a VPN generally works is you have your client that connects to some compute engine instance that's running your VPN. There's a socket connection between the two. They're exchanging encrypted data, and then the compute engine instance or the proxy will actually go out into the fantastic internet and do all your fetching for you, return that data back to your computer. This is a high-level approximation. If there's any security engineers in the room, I apologize for generalizing that to a point that I can fit on a slide. So let's look at the free tier here. How cheap could we make this? Well, if we use our instance as an F1 micro, then we know we can get that for free. And as long as our usage is about less than 1 gig, we know that we can basically get that for free as well, right? So if we're using an F1 micro and our usage is less than 1 gig, we can get a VPN that we can use whenever we want for free, every single month, using Google Cloud Platform. And if you go, and you only start to pay when you go over that free gig. So if you're just using this to log on to Wi-Fi hotspots when you're traveling around the world, you basically get this entire thing for free. No big deal. But here's one of the problems is that if you're using a preemptive version of that, you have a problem that you need to know where to connect to. And every time you reboot that VM, you have a new IP. Good news is, on Google Cloud Platform, you can actually reserve a static IP address. And as long as it's assigned and being used, it's free for you. So you can go in, create your instance, let it run, get a static reserved IP address that you can use from your personal devices that stick around waiting for you, and you don't pay anything, right? So again, we can run a personal VPN with a static IP for nothing each month. And again, if you eclipse the 1 gig free tier, that's when you actually start paying. Let's talk about two specific scenarios here. What if you want better bandwidth? So what if you're traveling and you actually want this VPN because you need to stream some video from some different location, right? Well, the important thing you need to understand is that the throughput for a GCE instance changes based upon the core count. It's actually capped at the core count. So the more cores you have, you can see here that, that on the side there, we're at our 64 and 32 cores. The more cores you have, the higher your TCP throughput. And this is where a lot of people get caught up when they're trying to increase their bandwidth for their VPNs, right? Because you'll notice that then if moving up from the F1 micro, the next available option is the F1 small, which you would want to use because that's going to be one of the cheapest. However, you notice because the number of core count is the same, we actually don't get any better bandwidth by moving to there, even though it's only $14 a month. Moving on to the next one, the actual first stage you get where you actually get some bandwidth increase is actually the N1 standard. So unfortunately, if you're moving up and trying to get better bandwidth, to even get it there, you have to start paying $24 a month for your VPN instance. Unless, of course, it's preemptive, in which case you get it down to $7 a month, but then you have to deal with what happens when you're in the middle of a session and your VPN decides to die. So let's talk about something I deal with a lot, traveling, right? So a lot of us are international nomads. We spend a lot of time traveling around, going to conferences, talking to customers and whatnot. It'd be really nice if we had our VPN follow us, because if we boot up a VPN in US Central 1 and yet we're in Malaysia, we don't want to wait for our packet to go all the way to the US and then come back to us, because that's just going to make our experience bad. So I actually put together a little hack for this that I wanted to share with everybody. So it turns out that you can actually run the Google Compute Engine APIs from Google Cloud Functions. So I actually wrote a little web location that I host that when I load it while I'm traveling, it'll figure out what my location is. And in Google Cloud Functions, it'll figure out what the closest zone is that I can run an F1 instance. It'll kill whatever the previous VPN instance I have is and actually create a brand new instance as close to me as possible. So as I'm traveling, I can basically just click a single button, kill the old VM, and create the new VM as close to me as possible, no matter where I am in the world. Again, for free, because then I'm not doing more than 2 million invocations of Cloud Functions per month. So this is really nice. So if you want to get the people in your family using your VPN and maybe charge them $10 a month, this might be a nice little racket to play at Thanksgiving. All right. So let's talk about something a little bit closer to home for a lot of you, is a WordPress site, right? Anyone WordPress experts in here? A couple people? Still no caffeine in the house. I like that. I like that. We're closer to 9 a.m. now, and everyone's still sleeping. This is good. So WordPress is a large and unwieldy beast, right? There's lots of different components involved and lots of different ways you can take this. So when you actually Google for WordPress Google Cloud Platform, the first thing you're actually introduced to is a page for our Google Cloud Launcher with all of these pre-configured operations that allow you to one-click deploy a WordPress instance to your Google Cloud account and just get up and start moving, right? So you can click any of these, and they have a bunch of different configurations of how you want it all set up. However, the default setup for this is actually less than ideal from an expense perspective, right? So these are all going to be set up with an N1 standard one, which is $24 a month. And of course, you're still paying that 12 cents outbound egress from there, right? So this is putting us in something we've seen before. But let's talk about complexity here. So what if you're using the simplest WordPress site possible? Well, obviously, you don't need, and you're only using a single instance, right? Because you don't have that many number of users. Well, you can actually use the F1 micro for this instead, which is free per month. And again, if you're under 1 gigabyte of outbound egress, you can actually get that for free as well. So if you're a brand new startup, right, and your friends are all like, hey, go sign up for this website over here, it's $10 a month to host your WordPress site, and you're still living on ramen, right, out of the VC incubator, along with 40 other people, this actually saves you that $10 a month to buy more ramen. Yay. But the question that we have then is the concept that we're free as long as we're under the free tier. And this is something I've been harping on for a while, is what is the cost before we eclipse that, right? So if we assume that we've got network of 1 gigabyte free, and our default WordPress site that you deploy on App Engine is about $272K per visitor, it means you can get roughly about 3,800 visitors a month before you eclipse that bandwidth and actually have to start paying. And this is a really important number for startups, for the hustle and flow type people, right? Knowing how many visitors you can actually take before you have to start paying money, and where you want to start optimizing all of that data. And of course, we could go into a massive diatribe about how to properly optimize your images and compress your headers and serve all that data. That's a different talk. Right now, we're just talking about the fundamentals, okay? So right here, we basically say if we're under roughly about 4,000 users a month, we should be okay and always in the free tier, right? And of course, if you turn on caching headers, that'll put things going into the CDN, so it'll increase this number significantly, because the more users you have, they hit the same content, doesn't come out of your main bucket, it comes out of a different bucket, and you get a lot more users to hit your information. But what if you actually end up on the top of Hacker News suddenly, and you need to start scaling up and down? Well, the cool thing here is that putting the load balancer between the CDN actually lets you do this. You end up with the same egress, right, 8 cents per gig outbound, and the same fill, 4 cents per gig fill. And we can actually end up with the F1 micro. The problem now we have, though, is because we have a number of instances instead of a single one, you need a persistent MySQL instance for each of your compute instances to be able to sync between. Now, unfortunately, as of today, I could not find a way to get a free tier setup with the SQL instance. So that's going to be around $29 a month. So if you're above that 4,000 user mark and you're expecting scaling, the minimum cost you're going to end up paying is around $29, just to make sure that that Cloud SQL instance is sitting around. Or you could run it on your own N1 standard or F1 micro and deal with all of the provisioning and everything else yourself. Now, it's worth noting here that there's also a plugin for App Engine. So if you're running WordPress and you want to run it on App Engine instead of dealing with all that other stuff, you can actually run it on an F1 micro instance or F1 instance on App Engine and get that down to about $0 a month. Unfortunately, you still need the SQL scalable backend, which runs on its own instance at about $29 a month as well. So something to think about. In general, if you're doing WordPress on Google Cloud Platform, I got to tell you there's 3 strata you need to think about to make sure you're really thinking about your shoestring style budget. If you're under 4,000 visitors, just use an F1 micro and turn on the CDN, and you'll basically get the whole thing for free, which is fantastic, right? That's where we all want to be. If you're above 4,000 visitors, then you need to start thinking about stringing together Compute Engine plus the load balancer plus the CDN and plus the SQL option, or using App Engine to do the same. Because you have enough users there, you need to start making sure that you're doing things properly. However, I got to tell you that there is a number of hosted WordPress companies that have their backends built on Google Cloud Platform that do offer you a subscription-based service. So paying $4 a month, they'll host your WordPress site, they'll deal with all the scalability, they'll deal with all the security updates, they'll make sure everything is running in the background, you don't have to lift a finger, and it might be a cheaper option for you to fall into that bucket if you're above 4,000 visitors. So that might be something to look at too. All right, final topic for the day, video content site on the shoestring budget. So with these things in mind, we have to look at what it would take to make like an education website or like an online MOOC, right? You have students that log in, they have some data they want to look at, they watch some videos, they take some tests. You know, maybe you have maybe a sports site that's streaming all of your high school sports games, and you've got a lot of video that you need to transfer. But you have some combination of rich multimedia and rich website presence, right? So with a standard layout here, you would probably have to store that video data in Google Cloud Storage, right? And serve that right to the user so that you can get streaming capability, right? You don't want that going through a proxy. You want that coming straight to the source there. On the website side, you probably have an Apache instance or maybe a WordPress instance that's actually hosting your website. It's got some connection to some relational database, right? So it can keep track of who the users are, what data they've seen, and any other keywords that you need. And then, of course, you've got your standard load balancing and CDN in front of that, so you can scale up, scale down, and make sure that your data is consistently sent to users around the world. This gets pretty pricey, unfortunately, right? You're looking at $24 for the compute engines per instance a month. You're looking at $29 for the Cloud SQL instance. Of course, you've got your fill and your egress costs. But where you really get hit here, of course, is serving that video. Now, as of today, and again, this can change in the future, internet, if you're watching this sometime in the future, as of today, the Cloud CDN that's coming from Google Cloud Storage does not cache 206 responses from an HTTP header. 206 responses are the ones that are used for streaming video, which means as you're streaming video, it's not going through the cache, right? So we have to be very cautious of this, which means we're going basically into the 12 cents per gig ratio if we're streaming data directly from Google Cloud Storage. Not really ideal. This whole thing can get pretty costly. But there actually is a solution if you're willing to make a couple changes. We can get this almost down to free instead of all of this cost. So first off, if you're willing to make some changes, leave your CDN in place. But instead of actually using a dedicated compute engine instance, switch over your page serving to be something invocation-based, like Cloud Functions. Minimize all of your crazy complexity down to something that it can use a template for, to just scrape the data together, put it together, send it down in the HTTP request as easy as possible. Make it invocation-based. You don't really need to do that much in the back end, right? And as long as you're under 2 million page views a month, you can basically get that entire serving process for free, which is pretty nice. Likewise, instead of using Cloud SQL, try to use Cloud Data Store for your relational database, right? If you're on a shoestring budget, Data Store will still give you the performance you need because most of it is fetch-based if you're using a website like this. And it has its own free tier, right? If you're under 1 gigabyte of stored data and you're doing less than 500,000 reads and 100,000 writes per month, you basically pay nothing, which I think this is right in the range of a MOOC-style startup, because you don't really have all the visitors you need yet, and even the successful ones are probably not doing 500,000 or 100,000 per month. And a gigabyte of relational data is actually a lot in that scenario. So we can basically get our entire website serving and backend storage for about $0. Now, the problem, though, is what do we do about the video content, right? Because there's no real other place to store this in Google Cloud Storage because 206 responses. My only solution here, a little bit of a hack, store all your video in YouTube. Upload your video to YouTube, leave it as unlisted, right? And basically, when you're streaming your embedded URLs down to your user, obfuscate the hell out of your code so they can't figure out where the video URLs are. If you can set it up this way, you get the entire content serving and video production platform for free. A lot of chuckles, yes. This slide is very contentious internally. We had a lot of talks. We had a lot of talks internally about whether or not that last little animation should be in this talk at all. Yeah. So with that, I want to thank you for your time today. I want to thank you for being the hustlers and the grinders, working on your costs every single day. I want to thank you for waking up this early to hear another bald man rant at you. Most importantly, if you care about cost, if you care about the performance of your cloud applications, I got to encourage you to check out our YouTube channel for Google Cloud Platform. We have a ton of amazing people working on amazing content to help you lower your costs, increase your scalability, and basically get your cloud application to where you want it as cheap as possible. With that, thank you. Stay sunscreened, stay hydrated. Enjoy your last day of Google I/O. Thank you very much.